Hey, we're back. We're going to talk about measuring energy changes. In this section, we're going to ask, how is heat measured? Well, there's a couple of different things you need to know. There's a couple of units that we use very often. One is a calorie, and a calorie is the energy required to increase the temperature of 1 gram of water 1 degree C. And we abbreviate that with a little CAL. The other unit, joule, is the energy required to apply a force of 1 Newton over a distance of 1 meter, and we abbreviate that with a capital J. Now, that doesn't make much sense to chemists. It makes more sense to physicists, but it's a unit of energy in the metric system. So, for our purposes, just consider that 1 calorie equals 4.184 joules of energy. Now, you may be familiar with another unit of energy in food, called the calorie, strangely enough. However, this calorie has a capital C, an uppercase C, and it's equal to 1,000 little c calories, or we sometimes call it 1 kcal. And 1 kcal is really the convention in Europe for measuring energy in food. So we use calories with the big C. In Britain, they use kcals to represent calories with the big C. Well, if we have to convert back and forth between the two, it's actually pretty simple if you remember this one important number, 4.184 joules per calorie. So if we have 60.1 calories and we want to convert that into joules, we then multiply by 4.184 joules per calorie. Because what that does is, that makes these units here cancel. One you want to get rid of goes in the bottom, the one you want to keep goes on top, so our answer is going to be in joules, or 251 joules. We can also go back the other way. We can convert 28.4 joules into calories simply by dividing. So the one we want to get rid of always goes on the bottom. In this case, we want to get rid of joules and come back with calories. The one we want to keep has to be on top. So this J cancels this J, leaves us an answer in calories, which is 6.79. So that's really all there is to it, to go back and forth between calories and joules. So let's try an example. Let's calculate the amount of energy required to raise 7.4 grams of water from 29 degrees C to 46 degrees C, and we want the answer in joules. Well, we know that 4.184 joules are required for every gram degree C, so we multiply by 7.40 grams, that's the total mass, because what that does, that makes this gram cancel. And then we multiply by the temperature change, which here is 17 degrees C. And look, this C cancels this C. One's on top, one's on the bottom. Got joules left over. We multiply 4.184 by 7.4 by 17, and we get 526 joules of energy required. Got a couple more here. One is to calculate the amount of energy to raise the temperature of 1 liter of water from 25 degrees C to boiling, which is at 100 degrees C. Do it in both joules and calories. And just to give you a hint, the answer is 3.14 kilojoules and 75 kilocalories. So why don't you pause the video, try to figure that one out on your own using what you learned up here. Okay, pause now. Did you get the right answer? Well, let's see. If not, follow along with me and we'll fix this up. Well, we start with 4.184 joules per gram degrees C. We have 1 liter of water here, and 1 liter of water equals 1,000 grams. So we have to then multiply by 1,000 grams of water per liter, and hey, look, gets this gram to cancel. Now we've got to figure out how many degrees it needs to go up. Well, we always subtract the final temperature from the initial temperature, so 100 degrees C minus 25 degrees C, well, we know that equals 75 degrees C, so we'll just put that in here, okay. And now we just multiply across. 4.184 times 1,000 times 75 equals 314 kilojoules. Or you might have gotten 314,000 joules, which is the same as 314 kilojoules. Now, we want to change that into kilocalories. So, we take our 314 kilojoules, and we then have 4.184 kilojoules per kilocalorie, and that gives us an answer of 75 kcals. Oh, well, these K's really just cancel each other out. So, 1 kilocalorie is the same as 4.184 kilojoules. So here, if you're kind of stuck with that one, you can try this one. Calculate the joules of energy required to heat 454 grams of water from 5.4 degrees C to 98.6 degrees C. And the answer, and we'll do it in joules this time, is 1.77 times 10 to the 5th joules. So if you want to pause, I'll give you a minute to solve that, and then I'll come back with the answer. Well, we do this exactly the same way. 4.184 joules per gram degree C. Well, how much do we have? We have 454 grams. 454 grams of water. Oh, that's going to make the grams cancel. Now we just got to find a way to make the degrees C cancel. So we then multiply by the difference in temperature. So we subtract the first one from the second one. So 98.6 minus 5.4 degrees C. We get that difference. We multiply it all the way across. We get 1.77 times 10 to the 5th joules. So, I've already used 7 minutes of video, so what I'm going to do is I'm going to stop it right here and start a new video on QSMAC.